Good afternoon. Myself, Dr. A. M. Takle, working as Associate Professor in the Mechanical Engineering Department. Today, we will study alloy steel. We know that in a FFE3 diagram, the main base is iron and carbon. In a steel, the carbon percentage is up to 2%, and in cast iron, carbon percentage is from 2 to 6.67%. The main base is the Fe and carbon, and we are adding some alloying elements like silicon, manganese, magnesium to improve the properties of alloy steels. So, they having various advantages, various applications of these alloy steels. We will study one by one. In this presentation, we will explore the word of alloy steel. We will learn what it is, how it is made, and the many different properties that make it such a versatile material, because by adding various alloying elements, the material becomes versatile because it improves the various mechanical properties and any other properties. We will also discuss some of the most common applications of alloy steel in our everyday lives. We will discuss the application of these alloy steels because the main constituent of this steel is a carbon and iron, and we are adding some alloy other elements to improve the property. So they are mostly used in various applications. So in this we will discuss some of the most common applications of these alloy steels. First we will study what is alloy steel. Alloy steel is a type of steel that is made by adding other elements to iron and carbon. I already told that in a FFP3 diagram the main base is carbon as well as iron, and we are adding some other materials in that plain carbon steel to become alloy steel to improve properties. These elements such as chromium, nickel, molybdenum and vanadium are added to improve the properties of the steel. To improve the property of that plain carbon steel, various elements like chromium, nickel, molybdenum and vanadium, and apart from this, that silicon, manganese, magnesium are the various elements added to improve the property of the steel. Compared to plain carbon steel, alloy steel offers greater strength, hardenability, corrosion resistance and other desirable qualities. Before adding these other elements, the main base is a carbon and iron, and this if the carbon percentage is less than 2% and only base is a carbon and iron, this steel is called as a plain carbon steel. Again, there are three types of plain carbon steel: low carbon, medium carbon and high carbon. And when after and this plain carbon steel having poor strength, poor hardenability, this material is a corrosive material compared to alloy steel by adding other elements. By adding that other elements, we were getting very good strength, hardenability, that's the hardness, and corrosion resistance. This material becomes corrosion resistive and improve their properties. Plain carbon steel, which is mostly iron and carbon, is a good starting point, but it can be limited in its capabilities. By adding specific elements, metallurgists can create a vast array of alloy steels, each with a unique set of properties for specific applications. Now, plain carbon steel, which is mostly iron and carbon, iron and carbon is the material base for plain carbon steel, and to improve that properties, that plain carbon steel we are adding specific elements, so its property will increase and it can be used for specific applications. How is alloy steel made? That is the manufacturing of alloy steel. Alloy steel is made using a multi-step process. Raw materials like we are founding that alloy steels in a foundry also, because alloy steel foundries are also there in which that alloy steel is manufactured. There are some basic steps through which alloy steels are manufactured. Raw materials like iron ore, coal, and other alloying elements are collected and processed. Raw materials like iron, that Fe, coal, through which we are getting carbon, and alloying elements are collected and processed. And another alloying elements are collected for the processing. The iron ore is converted into pig iron in a blast furnace. That iron ore is converted into pig iron. It converted into pig iron, which is required to form that alloy steel, and that pig iron is formed in a blast furnace. The pig iron is then refined to remove impurities and adjust the carbon content in a basic oxygen furnace. In basic oxygen furnace, that pig iron is refined because that impurity are present in a pig iron, and to remove that and to adjust that carbon content, this material is operated in a basic oxygen furnace. Alloying elements are added during the refining process. During that refining process, the alloying elements are added. The molten steel is then cast into slabs or billets. Then that alloy steel, when that elements are refined, that molten steel is formed, and that can be formed into slabs or billets. Billets means in a rectangular shape blocks. Finally, steel may undergo further processing such as hot rolling, cold rolling, and heat treatment to achieve desired properties. After that billet is formed, they will go to various processes like hot rolling. Example, hot rolling is a forging process, then extrusion process. Then it will be undergo to the cold rolling, that is uh, two roll process, three roll process, punching, blanking, like that. And heat treatment we are doing for that normally for wear resistance and to improve the mechanical properties. So this material can be go undergo heat treatment process to achieve the desired properties. The exact process for making alloy steel can vary depending on the desired outcome. However, the basic step outlined here provide a general overview of how this versatile material is brought to life. These are the general guidelines to manufacture from the wrought iron to the final steel, that formation of pig iron and remove impurities. There are various types of alloy steels. There are many different types of alloy steels, each with its own unique property. Some of most common types include low alloy steel, high alloy steel, tool steel, and stainless steel. First, we will see low alloy steels. The name itself implicates that the alloying element percentage is less in a low alloy steel. These steels contain a small amount of alloying elements less than 10%. The other alloying elements like magnesium, manganese, sulfur, chromium, silicon, vanadium, molybdenum. The total percentage of alloying element, if it is less than 10%, then it is called as a low alloy steel. They are include they are known for their good strength, toughness, and weldability, and they are good for strength, that ultimate strength, yield strength, improving also toughness, that is to sustain that impact load, and weldability means it is easy to welding. And these are applications used in buildings, bridges, and automobiles. These alloy steels are used in the buildings, bridges, and automobiles. High alloy steels. This steel contain a higher amount of alloying element more than 10%. If alloying element percentage is more than 10, then it is called as a high alloy steel. They offer superior properties such as high strength, corrosion resistance, or heat resistance. They are used in a wide range of applications including aircraft, power plants, and chemical processing equipments. If percentage of alloying elements is more than 10, it is called as a high alloy steels. And this material is having high alloy steel materials is having high strength, more strength is there. Their corrosion resistance, that is less corrosion is there, heat resistance, and there are various applications including aircraft, power plants, and chemical processing equipments. Then tool steel. These tools are normally used for in a cutting, manufacturing of dies, molds. They are used. These steels are specifically designed for cutting, shaping, and forming other materials. They are known for their exceptional hardness, wear resistance, and heat resistance. Common applications include drills, nails, and dies. I already told that these tools still are used to manufacture drills, dies, molds because they having very good hardness, wear resistance. This is the main property required for cutting operation during cutting operation to tool, that is drill. It is wear resistance and dies are also wear resistance. Stainless steel. These steels contain a minimum of 10.5% chromium, which gives them excellent corrosion resistance. We know that normally we are using stainless steel because of its corrosion resistance, and this corrosion resistance is increased because of addition of chromium. So, in a stainless steel, the chromium percentage is about near about 10.5%. They are used in a wide variety of applications where hygiene and durability are important, such as cookware, medical instruments, and architectural components. I already told that they are used in a cookware because our glasses are manufactured from stainless steels, medical instruments like orthopedic implants, and architectural components because of that corrosion resistance. Properties of alloy steels. Alloy steels offer a number of advantages over plain carbon steel, including increased strength. The strength of alloy steel is more than plain carbon steel because of that increase because of addition of that alloying elements. Increased strength. Alloying elements can significantly increase the strength of steel. This makes alloy steel ideal for applications where high loads needs to be supported. That it is useful to improve strength of the material, improved hardenability. Some alloying elements can improve the steel's ability to harden during heat treatment. The hardness will increase. This makes it more wear resistant and durable. As the hardness increases, it becomes more wear resistant. Enhanced toughness. Certain alloying elements can improve the steel's toughness, making it less likely to crack or break under stress. The toughness of the material will increase, so it making less likely to crack or break under stress. It will not break or crack under stress. So we will get that very good toughness property and it will sustain the impact load. Better corrosion resistance. Some alloying steels are better corrosion resistance because of addition of chromium percentage. The application of alloy steels. The various applications of alloy steel include alloy steel's versatility stems from the ability to tailor its property through various elements. Here is a breakdown of its application across different sectors. First one is the construction. Because of strength and durability, alloy steel is backbone of modern construction due to its superior strength to weight ratio. It is used in skyscrapers, bridges, beams, columns, support structures, building, reinforced bar, concrete slab, and wall panels. Pipelines for transportation oil, gas, and water due to strength and weldability. Transportation, strength and weight reduction. It is used in a car, trucks, and airplanes. Utilize alloy steel because of alloy steel having high strength to weight ratio. That is, strength is increased and weight is reduced. So it is used in a gas truck, airplanes. Automotive frames and components offering a balance of strength and weight reduction for improved fuel efficiency. Skip building plates, hulls, critical components requiring high strength and alloy resistance. Aircraft landing gear needing immense strength to handle heavy landings. Manufacturing and machinery strength, wear resistance, and high tolerance, heat tolerance. Alloy steel keeps industry running smoothly. They are also, because of that strength, wear resistance, and heat tolerance, they are used in gears, shafts, bearings, also in cutting and drilling tools, heavy machinery components. Because of that high strength, high temperature, and corrosion resistance, alloy steels are used in energy generation equipment like power plants, oil and gas drilling equipment, consumer goods. Because of that high strength, corrosion resistance, and aesthetics, even everyday items can benefit from alloy steels, and its application includes washing machine, refrigerator, and ovens, cutlery and cookware, sporting goods like bicycle frames. Thank you.